Physics! I wanted to come on and kind of show you how to solve these in case you were confused about them. The series ones aren't so bad, they're kind of self-explanatory. Parallel is a little bit more tricky, so that's the one I'm going to show off here. It's parallel. So we have a parallel circuit here, and we have our 3 rules that we need to make sure that we follow for things in parallel. For my example here, I have nothing filled in. On your worksheet, you do have some things filled in, but I don't. But I'm going to show you how, if you are given a circuit, you can fill in all these boxes without having anything else given to you. Okay? So here we go. Let's start. Let's start by filling out some stuff. First off, your total voltage is going to be 9. Okay. Our total amps, we don't know. Our resistances of each of our things here, each of our resistors here, resistor 1 is 10, resistor 2 is 2, and then resistor 3 is 1. Okay? And that's about all we can fill in for parallel right away, because unfortunately for resistance you have to use a specific equation to do so, or you need to figure out both of these in order to figure this total out. Okay? If you're stuck here and you don't know what else to do, you need to take a look at your 3 main rules to see if they can't help you out, because they're kind of like hints. So let's look at our first rule. It says all components share the same voltage, meaning that the voltage is the same in each branch, and that equals the total unless you have other resistors also in series on your circuit. So in this case, we do not have any other series resistors, we just have 3 in parallel, okay? And the voltage that's going through each of these branches, as it says, the voltage is the same in each branch, so each branch is the same, and it equals the total if there's no other series resistors. So since there's no other series resistors that go along with these, they're all the same, and they are all equal to the total voltage, which is 9. So the thing we put in all of these here is 9. 9 volts, 9 volts, and 9 volts. Okay? Now, we have our resistors put in here. As our second rule states, resistance is diminished to equal a smaller total resistance, meaning that the sum of our resistors is not what our total resistance is. Instead, we have to follow a specific equation for that, which is actually on slide 50. It's this one right here. I can show you how to use that in a minute. However, I'm going to show you another way you can find resistance instead of using this equation. Okay? So coming back here, we can see that we have nothing in our current, in our I slot, in our current for our ampage, but we can look over here and it says branch currents add to equal a larger total current, meaning that the total of branch currents equals your total current. So that means that whatever we get in these 3 here equals to our total ampage, our total current, okay? And we have V, I, and R, and this should look familiar to you in that the equation that I gave you earlier that has all 3, V, I, and R, is the Ohm's law equation, which is this guy. I equals V over R. Okay? And so we're already set to like solve for I in this case, since we have V and R filled out almost entirely on both sides. All you have to do is find I in the middle. So if we take our calculator I equals V over R. So we take that and we go V, 9, divided by R, which is 10. So our current through resistor 1 is 0.9 amps. Okay? Our next one, R and 2, or 9 and 2, sorry. So we have 9 divided by 2, which is 4.5. And then lastly, 9 divided by 1 is 9. So then, once we have all of those filled out, you can read again our last rule here. Says branch currents add to equal a larger total current. So our total of our branch currents equals our total current. So all we have to do is add those all up together. So 0.9 plus 4.5 plus 9 is 14.4 amps. Okay? So notice we've done a pretty good job at filling everything else out. All we have to do is find R. And this is where it comes in that you don't have to use this equation. Notice we have V and I filled in. So we could actually just use this equation, I equals VR, and rearrange it to solve for R instead, since we have both V and I. So if we rearrange this to find R, so you can times by R, you know, let's see here. If you times by R on top, and over here times by R, sorry for my messy computer writing, but that gets rid of this R. Then all you have to do is divide by I to get rid of it on this side. Divide by I, which leaves us with R equals V over I. Okay, so we're going to use this equation to find our resistance. So if we go back, R equals V over I. So V over I, and so you take your calculator, V, which is 9, divided by I, which is 14.4, we'll find that our equivalent resistance in this parallel circuit is 0.625 ohms. I don't have the crazy symbol for ohms right now. Ohms. And so that's what our resistance is in total for this parallel circuit. Okay? Not too bad, right? And that's pretty much how you solve and find out what your voltage, current, and resistance is in a parallel circuit. Okay? If you wanted to learn how we use this equation here, the bottom one, to find our total resistance, I'm going to show you how to do that real quick in order to get this number. Okay? So what I'm going to do is I'm going to take my equation here and I'm going to bring it over to a fresh paint board. I'm going to slide it over here. Going to get rid of some stuff here, make some workroom space. And the trick to using this equation is actually only concentrating on this portion. Okay? So we're going to be taking our resistors, like our numbers that we had previous from back here. So all of our numbers, which were 10, 2, and 1, and we're just gonna place them down here as placeholders. Okay? 10, 2, and 1. Now if we remember from math, I know fractions isn't the funnest unit in math, but from what you can maybe remember is that you cannot add fractions like this. In order to add fractions, you need to have the same denominator on the bottom. So from this, what we need to know is we need to have the same number on the bottom. And to do that, you have to convert the fractions that don't have your common denominator on the bottom to match the common denominator. So in this case, since the top number can't go lower than 1, you have to look at the number on the bottom to find which one you have to use. So for in this case, since we can't go below 1 over here, that means this 10 can't be reduced. Okay? That means that 10 has to be our common denominator. So what we have to do in this case is use 1 over 10 as our starting point, and these other two fractions have to end up changing, okay? Where we want 10 as our denominator for every single one of them, okay? So in order to figure that out, we have to look at each of our fractions. This one, 1 over 1 is easy, so what is 10, what should be on top if it's something over 10? It should be, so 1 over 1, so that's clearly going to be 10 over 10. Okay? Then for our second one here, all you have to do is think what on the bottom, so what times the bottom is going to be equal to 10. So to know what you have to times the top number by. So in this case we have 1 over 2 is the fraction we're trying to convert. I know a lot of you are saying it's 5, and yeah, I'm just showing you how you use it in case it's not an easy fraction. So you have 1 over 2 and you want to be something over 10. Okay. So 2 times what is 10? In this case, yes, it's 5. Okay, 2 times 5. Oops, sorry. And so we're going to be doing that for both up and down. Okay, the numerator and the denominator. Okay, Oop. Take that. I'm going to be doing that to both upside and downside, okay? To find out what your top number should be. So 2 times 5 is 10, which is what it should be, and then 1 times 5 is 5. So 5 over 10 is going to be the number that we have. Okay? Get rid of my work progress over here. So once you've converted all of your fractions to have your common denominator, now what you have to do is you have to take that and add it. Okay? So what does that equal? You just gotta add it all up and have it over 10. So in this case, 10 is always going to be on the bottom. And then for our top number, it's 1. Plus 5 is 6. Plus 10 is 16. So 16 is our top number, is our numerator. And if you think about it, all we've done is figure out this bottom portion right here. So technically, if you're thinking about it, then our whole entire equation should be 1 over 16 over 10. This is essentially what we just figured out. However, this thing right here, it's beastly to look at, and all you really need to know is that this right here is essentially just going, oh, I'm gonna flip this bottom part upside down. Okay? That's all you're doing. You're literally just turning that upside down. So instead of 16 over 10, now it's going to be turning it upside down. So now it's 10 over 16. So then if you'll notice, if we take 10 divided by 16, we get 0.625, which is what we got here. Okay? So in reality, if you had just figured out 10, 2, and 1 on your resistances, you could have found this out right away by using this equation and figuring all this out. Okay? For me, it's faster to do it the way I showed you, by figuring out what V and I were first before figuring out R with Ohm's equation, because for me it's just faster. For some people, fractions are easy, and so they can do this process super quickly to find out what their resistance is. Okay? For me, it's not so easy, and so I usually like to do it the other way. But for some people, they can do it this way really quickly. Okay? I just wanted to show you how you actually use it in case you come up with other numbers that you can easily make into fractions, or if it's just plain easier for you to use it this way. Otherwise, I would try and default to the way I showed you over here by using Ohm's law and your total volts and total current to find your resistance. Okay? But yeah, hopefully this helps make more sense for you guys. Otherwise, let me know. I'm going to try and put together a series one so that you can see what that looks like as well. Alright? Let me know if you guys have any questions, and I'll talk to you later, okay? Bye!